So as we think about making powerful, impactful, compelling data visualizations, remember we have these three pieces that we're trying to work on. What's our business question? Once we have our business question, what are the data in our data set that have something to tell us about that the business question? And then finally, what chart type matches best with the previous two, the question and the data. So the data part, though, begets a kind of more basic question of what are data? Like what do we actually mean? And I think people throw these things around and they don't actually have a firm definition. So we need to make that firm to begin with. So when we say things, we know what each other is actually referring to. So let's start by disambiguating two terms, variable and data. So a variable is any characteristic or quantity or quality that we can measure or count or categorize. Is something that we can precisely describe, something that we care about that we can precisely describe. Whereas data are the actual observed values of a variable. So a variable is like a concept, a data is concrete. And you might have different data for the same variable. For instance, you might have nationality as your variable, and you have the nationality of group A and you have the nationalities of group B. Those are separate pieces of data on the same variable, related to the same variable. And this, I only bring this up because it's going to be really important, because it's going to be a way in which we can merge data sets together. Much more on that later in the course. But for now, variables are conceptual ideas, things that we care about, things that we want to count or measure, classify or whatever, and the data are the actual observations of the variable itself. So just to completely beat a dead horse, if we have our variable age, that can be measured in a ton of ways, right? It can be measured in days, it can be measured in seconds, it can be measured in years, but the data are the actual observations, however we choose to precisely quantify age. So here it's in years. We've got 25 years, 74 years, blah, blah, blah. So we could also do transaction values rounded to the closest cent. Or we could also think about age not measured in years anymore, but kind of bucketed for young, old, middle-aged, etc. However we define those classifications. And the same thing for transaction value. It doesn't have to be numeric. It could be categories, high, medium, low. So again, we could have the same variable measured in different ways, same variable associated with different data. So data are typically organized into frames or sheets. Sheet is like the Excel terminology, like a sheet on Excel. Frame is much more like a data science term. You also see it called matrices or tables, things like this. So notice that each column in our particular data frame here, each column represents a variable. Each value is a piece of data, one datum. And each row are data that are associated with a particular observation. So the observation might be an order, the observation might be a person, the observation might be a transaction, whatever in your particular data set each row represents. But all of these data are tied together in one particular observation. So and it's just kind of by convention. Columns are variables, entries are data, or rows are observations. So to talk about data, we have to talk about the flavors that it comes in. And these are really, really important in ways that we'll talk about a little bit later. But the big breakdown is that data come in two big flavors, numerical and categorical. Numerical variables are also called quantitative variables. These are numbers. They may or may not have decimals. They may result from measuring or from counting. So measuring would be things with decimals typically. Counting or things without decimals, you just count like on your fingers. Categorical variables are often called qualitative data, and these qualitative data result from categorizing observations. So these are, you're putting it into buckets or something like this. So just to go back to our examples that we saw a moment ago, if we're thinking about age as numbers or transaction values rounded to the nearest cent, these would be numerical data associated with these variables. If we were thinking about the variables age and as young, old, and middle-aged, and transaction value is high, medium, low, we would be thinking about these same variables as categorical variables now rather than numerical. Again, oftentimes this distinction is illusory is not right. It's not an illusion, the difference, but we can convert from one to the other, and we can think about the same variable in multiple formats depending on our taste, how much we care about being precise, what tools we want to use, how we want to display things, whether small differences matter in a business context. Lots of different reasons we might move between numerical and categorical, but they do have fundamentally different kind of use cases and visualization, as we'll talk about. We can further break these things down in ways that matter. For categorical data, for instance, or categorical variables, for instance, they come in two subflavors. Nominal variables that have only a name, there's no ordering, and ordinal, so the ord part at the beginning is ordered. These values have an order. The nom part at the beginning of nominal, it means name only. So nom is Latin, I think. It's either Latin or Greek. It always is in English, one of the two. So, for instance, if we have nominal variables, things like nationality or relationship status, these are nominal variables. They don't have any particular ordering. Now, I actually had a student last semester push back on this. They said, actually, I think relationship status should be ordinal, because first you're single, then you're married, then you're divorced or widowed or something like this. And I was like, yeah, I can kind of understand that. The problem will be if there are two categories that you can't actually put quite in a particular order, like divorced and widowed, for instance. You may not know which of those should come first, and if you can't specify an exact ordering to the variables values, then it's not ordinal, it's nominal. So, but again, there can be gray areas here. Things like ordinal will be young, medium, young, old, and middle-aged, and high, low, medium, things like this. Clearly, there's an ordering to those things. Numeric variables come in two flavors too. Discrete and continuous. So discrete is a variable who has a small number of values, possible values, and they almost always don't have decimals. So they're things that result from counting and counting a relatively small number of things. And continuous is a variable that can have decimal points and potentially many, many decimal points, and there are infinitely many possible values. Why does this matter? Like it does matter in the sense that the way you might want to deal with, for instance, like a star rating, which is 1 star, 2 star, 3 star, 4 star, 5 star, might be fundamentally different than the way you want to deal with stock value. Like the way you might want to show these two variables might be very, very different. And when we boil this down to the most fundamental distinction between these two variables, it's that one of them is discrete and one of them is continuous. And we'll talk much more about that as time goes on. But it does point us to one really big idea. The reason we care so much about this and all these distinctions and why we have to know all of these definitions before we even start is because everything we do from now on depends on the type of data we want to display. Whether that's a single variable, whether that's a pair of variables, whether that's a bunch of variables in the same plot, every single decision that we're going to make going forward will fundamentally depend on the type of variable that we're trying to display. And so the very first thing we have to know is we have to be able to look at a variable and say, it's this type of variable. After we have that part down, the next part will be, well, given that I have a nominal categorical variable, the following ways are available to me to display this particular piece of particular collection of data. Or if I have an ordinal categorical variable, I should display it this way. Or if I have an ordinal categorical variable and a continuous numeric variable, here's how I should display it, and so on and so on and so on. We have solutions for a bunch of different situations, but in order to know which solution to use, we have to know what variables we have. Otherwise, if we don't have this key step here, this is where the confusion starts, because people are just throwing stuff in there and hoping for the best with no kind of guide for best practices about how you should be displaying the data that you have. So I know that's a little bit cart before the horse. We actually have to talk about these design elements. We have to talk about these visualizations, and all of that will come. But we have to have this kind of ground layer of variables and data before we start.